Yeah, welcome back to the continuation of permutation and combination series. In this video, we are looking at conditional permutation. And the previous video before this one, we talked about the condition that they must always stay together or stay together. Here, I want to look at a situation whereby they must never stay together, or they must never stick together. Or sometimes we say a letter must separate another set of letters so that they shouldn't come together. By the end of this section, you should be able to arrange objects in a row on condition that two or more objects must not stay together. Once again, we'll use example to explain this concept. So the first example, find the number of ways in which the letters of the word shallow can be arranged if the else must not be together. If the else must not be together. So we can take the else out. We are saying they shouldn't be together. So when we take them out, they are the condition. They will treat them separately, how to handle them. And so now after taking the two else out, remember the two else supposed to be here. So it means they are supposed to be here to make the shallow. So I've taken that out. Now the question is, in how many ways can I arrange the remaining letters without the two L's? Here there is no repetition, you can see that. So we are going to get it as 5 factorial ways. Now, because the L's must not be together, they are supposed to be positioning themselves in between the space that we have here, right? So if I put one L here, then the other L shouldn't be here, shouldn't be here. It can be in any other place. If I put one L here, the other L shouldn't be behind or ahead. So that is the condition here. So now we have 5 factorial ways in arranging the word S-H-A-O-W. Like we said, we have the remaining, how many slots here to arrange the L's? We have 1, 2, 3, 4, 5, 6 ways of arranging. And so we can say the first letter can position itself 6 times, right? Assuming we put the first letter here, then the second letter cannot be behind the first one or cannot be in front. So it has only option of position itself 1, 2, 3, 4, 5, and then we multiply by 5. And once again here they are not to remain together and they are separated. So at any point in time you see them separated and they are repeating the same letter. You see L here, the same is L, and so we divide by 2 factorial. Remember that if we are perming a set of letters and some are repeating, we divide by the repeated ones. But the previous one we didn't divide by anything because they were together as one, but here they are separated, so we divide by 2 factorial and the answer will come as 1800 ways. Let's take another example to explain further. In this question, we are looking at how many ways 3 women and 4 men sit in a line if no 2 women sit together. If no 2 women sit together. Right. You can pause the video and try it, or we just do it together as such. Now, we want to keep all the 3 women apart. If we keep them apart, we are left with 4 men. And the 4 men, if you arrange them in a line, they can be seated in 4 factorial ways. Do you agree to that? So the men will give us 4 factorial ways. Now, aside them being 4 factorial ways, in between the men, we have 1, 2, 3, 4, 5 different ways. Any of these can position themselves. Because they must not be together, when one sits behind and in front, there shouldn't be other woman. Alright, so the question is, the men can be seated in 4 factorial ways. Now, the first woman, any of these 3, can be stated in 1, 2, 3, 4, 5 different ways. So we can say times 5. If the first woman takes her seat, once again, the next woman cannot sit behind this way, cannot sit in front here. The next woman has only the option of sitting 1, 2, 3, 4 different ways. And so that will give us times 4. And bear in mind, this is not going to be 4 factorial or 5 factorial, because it's just the position that one woman is going to position herself. You are getting it? And so now the next woman, let's assume the next woman take the position. This third woman here, because they must not be together, cannot sit behind first woman, cannot sit in between the woman 1 and man 1, and cannot sit also over here, because the moment she comes here, that means they're going to be together, and she can also sit here too as well. So the only option is 1, 2, 3 different ways. And listen here, the women are separated, and they are different, they are not repeating, so you won't divide by anything, and so this becomes your answer as you multiply. I hope it makes sense. Take your time, go over again, and then, or you can play back the video and then analyze everything systematically on your own. Let's take another example. You can pause this video and try this question. Alright, so what is your answer here? Did you get 120 ways? If you did, you can clap for yourself. If you didn't do it, then it means I know your problem. Did you consider the fact that the CC are repeating of the first set, and then the X that are supposed not to be together are also repeating? Now this is what you have to do. Take away all the X and you have UCCE. So the question is, in how many ways can you arrange UCCE? These are four letters, so we could say 4 factorial, right? We could say 4 factorial, but then the C's are repeating, so we divide by 2 factorial. Then after arranging UCCE, you have 1, 2, 3, 4, 5 different spaces for the remaining 3. Now, any of this can be positioned in 5 different ways. So I multiply that by 5 ways. Let's assume a position X. Then one X has taken the position, so we are left with 2X. And once again, they are not supposed to be together, so the next X cannot be here as well. So the only option left is either 1, 2, 3, 4. And so that will give us 4 ways of positioning the second X. Now the third X cannot be in front, cannot be behind, and so we left with 3 different ways of doing that. But we are having 3X and they are not together and they are repeating, and so we divide by 3 factorial. So that will end up giving us the 120. I'm sure that is nice. Good. The remaining questions are for you. In how many ways can you arrange the letters in the word percentage if PR must not come together? And once again, observe the repetition, because E, and E will repeat. Alright, I'm sure your answer came as this. Beautiful. The next question, try it again. And when you are done, you're supposed to get 36 ways for the first one and 24 ways for the second one. You can pause the video once again and try this. And if you do it well, your first answer will give you 1,260 ways. The second answer will give you 6,300 ways. Then your last question is this. So matrix and conditions are TR must always be together or they must not be together. And once again, your answer will give you 240 ways and 480 ways. If you are sure you did it correctly and you don't get the answer that I'm giving you, don't get worried. You can show it to, you can even send a text message to me on my number or you WhatsApp it, and then I will see if really what you've done is correct and my answer is not correct. Well, with this, we come to the end of this section of the video. Stay blessed and thanks for watching.